All right. Good morning, good afternoon, and good evening, folks. Thanks again for joining us for another session of the Machine Learning Community Stand-Up. And hopefully you can hear me. We're having a few technical difficulties before starting the stream. So yeah, just welcome. Hey, Jason. Thanks for joining. All right. So I'm Luis. I'm the program manager for MLnet, and I'm so happy to be here talking to you folks about some of the latest work and latest developments in the world of machine learning and .NET. And with me is my co-host here, Xiaoyun, who's going to be showing us some really cool demos here. Xiaoyun, I don't know if you've ever been on the stream before, but would you like to introduce yourself?
Sure. So I've been there once, but it's a long time ago. So a brief self-introduction. My name is Xiaoyun Zhang, and I come from ML model builder teams, and really excited to be in these stand-up meetings.
Awesome. Yeah, I'm looking forward to some of the stuff that you'll be showing us later today. Let me just do something here real quick. So today we're going to be talking, or today's show is brought to you by the word n-gram. So typically we tend to do a term or a concept related to machine learning for each one of these sessions. So the term today is n-gram. So what exactly are n-grams? N-grams are basically this way of ordering words into a series of n numbers, right? So for example, a bigram would be sequences of two words from sentences or documents, whatever it may be. Trigrams would be sort of pairs of three words, right? And things like that. And these are really helpful for natural language processing tasks, right? So for example, if you want to do things like next sentence or next word prediction within a sentence, you can leverage some of these. You can leverage n-grams to help you do that with the help of things like, by calculating the probabilities of what is the most likely next word that's going to be coming up in a sentence. They're very helpful for basically trying to compare different documents, how similar documents are. If you're able to extract the different n-grams, you can kind of tell, how similar certain documents are. And to put it into, I guess, a little bit more concrete, right? Let's say that we have, for example, this is a bigram, right? And we had this sentence here. This is a sentence. A bigram structure might look something like this is a and a sentence. And then for trigrams, it would be something similar. This is sentence. So this is would be one of the trigrams, and then is a sentence is another one, right? So you can see here that order matters, and then the n in n-grams is just a number of words that you're associating with it. So that's n-grams for you. Before we get started, let me go ahead and share my screen here and talk about some of the things that are happening within the community, as well as some of the work that we've been doing here with ML.net, both on the framework side as well as on tooling. So let me share the screen here real quick. So to start off, we have this article here from the folks, and let me actually remove the banner here, and let me share the community links with you, which you're going to find there. I'll also paste it into the chat here. That way it's easy for you to get access to it. But you can find everything that we're going to be talking about today inside of the at that link there, at the URLs link. So again, to start off, we have this article here from Ryan Palmer over from Compositional IT, and basically it's just it's an example of using ML.net with recognizing digits. So this is your traditional sort of MNIST style sort of a problem, right? And in this case, it's using, in this example, is the use of ML.net with Fsharp, right? So so this one takes you through the process of getting the libraries or importing all of them. This is sort of the if you're familiar with Fsharp scripting or FSI, it's the way of referencing packages inside of those Fsharp script files, as well as notebooks. Goes through the process of importing data, preparing the data, and then configuring the trainer that's going to create a machine learning model that's going to be able to recognize digits. Okay, so if you're interested, if you're doing Fsharp, and if you're interested in how you might be able to leverage ML.net with Fsharp, here's a really great article for you to check out. We also have a few conferences and events that took place not too long ago. This is one of those, which is ML.net Day, which was a collaboration with the We Are developers. So this meetup group, the .NET user group from Zurich, went ahead and created a few sessions, one by Marco on object detection with ML.net, and the other one is a deep dive into ML.net and C#. Unfortunately, it seems like this one may have been canceled, but still, I believe that you can still check out the session, and the YouTube link, I think, is included here in the event page as well. Let me see. We have a question here from Sharafuddin. How do I remove unused source code in .NET Core project using machine learning? Unused references. Let me bring that up here real quick. Sharafuddin, could you clarify a little bit more in terms of what do you mean by these unused references? Is this like a project that you're creating? Is it code that gets generated as part of Model Builder? What context are you referring to this question in? Just go with this here also. Coming to us from another user group or event here is this event. So Global AI Bootcamp has a series of events that take place throughout the world. This one happened to take place in Spain. So for our Spanish-speaking audience, right, maybe this is something that you might be interested in checking out. Emiliano, in this case, did a few demos and did a talk on how to use Blazor with TensorFlow and ML.net for image classification, right, or image identification. So if you're interested in how you might be able to leverage these different technologies together, make sure to check out Emiliano's talk here over at the Global AI Spain YouTube channel. One of the user groups, I don't see the other one, but the Practical ML.net user group has had a series of sessions that have been very interesting. One of them is integrating scikit-learn ML models with ML.net using Onyx. So if, for example, you are working with data scientists who are working in Python and they are leveraging scikit-learn to build their machine learning models, one of the things that you can use in that case is Onyx to convert those models into a standard format, and then import that inside of ML.net, because you have the capabilities of you have the capabilities of using Onyx models for making predictions inside of ML.net, right? So if that's of interest to you, make sure to check it out. Let me go back here because there's also another session which happened most recently, and in this case, it was how to create and a deep dive into recommender systems. This was, I believe, something that was presented by Dino Esposito. So if you're interested in learning more about recommender systems and how you can use them with .NET and ML.NET, make sure to check out this session again over at the Practical ML.NET user group. And you'll also find a link in the URLs that I shared previously. Let me just see here real quick. I believe that we may have had a few more sessions here. Yes. So if you're interested in some of the other talks that the Practical ML.NET user group has, there's one coming up on April 13th. And this one, Praveen is going to be showing how you can use ML.NET to classify sounds, right? So if that's something that interests you, make sure to sign up for the event, and you'll be able to check it out. And if you can't make it, of course, there's always recordings as I showed you previously, right? So you can go over to their YouTube channel and check that out. Some updates. Let me actually start off with this one, right? So we updated our docs because we just had a release for the ML.NET CLI. So for quite some time with the ML.NET CLI, you were dependent on .NET Core 3.1, right? And so it wasn't up to date to .NET 6. So recently, about a month ago, we released the latest version of the CLI, which provides support for .NET 6. And in addition to that, you also have the ability to use it on different types of chipset architectures, right, including ARM64 and M1. One of the things that I would sort of advise or would like to make you aware of is that not all scenarios are going to be supported. For example, things like image classification are things that you can't are not supported for ARM-based devices. So just keep that in mind as you're using this. But again, you are now able to use it with ARM devices, on ARM devices, and you can use it to train machine learning models using the CLI. So make sure to go check it out if this is something that, if you're interested in using the CLI. With the CLI, one of the things also to call out is, if you were not familiar with it, is that it's cross-platform, right? Because it is just a .NET tool, it works across Windows, Mac, and Linux. So as opposed to Model Builder, which is Visual Studio only, right? With the CLI, you have a little bit more flexibility there if you're using it on non-Windows devices. But yeah. Which brings me to the next article here that we have. This is a blog post that was published by Becca here, who's also on the Model Builder team. And this basically walks you through the process of how you can set up training or retraining pipelines using the ML.NET CLI, Azure DevOps, and Azure ML, right? So let me kind of break this down a little bit. And MLOps and just this general automation workflow is something or an area that we're investing in. So in this case, there's three important things to sort of take into account. One is that the data sets that we're going to be using are the Azure machine learning data sets. If you're not familiar with Azure machine learning data sets, you can go on over to this link to learn a little bit more about what they are. But essentially, one of the things that data sets provide you is it allows you to host your data in the cloud, and just basically make it accessible outside of just your PC and your machine, right? But more importantly, one of the things that Azure Machine Learning Datasets provides you is versioning, right? So it's important when you train a machine learning model to try to understand and sort of get a sense of, which version of your data a specific model was trained with, right? Because ultimately, if you're trying to understand, well, why is my model making some of the decisions that it's making, part of that, or a large contributor to that, is going to be the data that it was trained on, right? So Azure Machine Learning Datasets help provide you with some of that versioning for your data sets, among other things. Now, the other thing to sort of call out here is that this is using the latest version of this Azure Machine Learning CLI, so the Azure Machine Learning CLI v2. Now, one of the nice things about the Azure Machine Learning CLI v2 is that, for the most part, the jobs tend to be container-based, and the processes that run are independent of the language, meaning that you are not required to run Python, or you don't have, your jobs don't have to be in Python, right? Which opens up opportunities for frameworks like ML.NET to run and .NET processes to run inside of Azure Machine Learning computes, leveraging the Azure Machine Learning CLI. And then Azure DevOps sort of comes in here, and it's sort of that process that allows you to just automate and have a repetitive, a continuous cycle of training and retraining your model, right? To sort of automate that process. But more importantly, again, similar to data sets where you have versioning, you're able to have builds associated with them with each retraining job, and you're able to get a lot more auditability out of these auditability and reproducibility out of your training and retraining jobs, right? So basically, this post walks you through how you can go ahead and do it yourself. Some of the prerequisites are going to be in Azure Machine Learning Workspace, which is just a space for you to basically collect all of your resources, including compute clusters, right, which are going to be used for training. Once you're in the Azure Machine Learning Studio, you can go ahead and create a data set. In this case, the song popularity data set from Kaggle is the one that was used. You essentially have to just as part of creating your workspace, you're provision a data store, right, which is just an Azure. It's an Azure blob storage account, right? And then once your data is in there, you basically just go ahead and set up the MLnet CLI. Now you're going to notice here that the steps or the installation instructions for creating this container-based image are basically the same that you would do on your machine, right? So there's that. Using the .NET SDK 6.0 base image, you just install the CLI, and then just set up some environment variables here so that the CLI is able to be recognized and set up that container process, right? Once that's set up, you're going to want to, in this case, it's a regression problem. So you go ahead and provide the commands that you're going to need to run this particular job. You configure things like the data set. In this case, it's the song popularity that's inside of the Azure ML data sets. And you configure this YAML file here. This is basically what the Azure ML CLI is going to use to execute your training job, right? In this case, obviously, you're filling it in with your own compute and a few of other things of your own. To run it manually, again, you just use the Azure ML CLI to create a job using that training file, this YAML training file that we just highlighted here and went over. And that's how you can just make sure that the process is actually running. And then last but not least comes Azure DevOps, where you just essentially create a pipeline. It looks very similar to, it has all these different steps, right, and configurations that you would otherwise, typically set up as part of your CI/CD type jobs. And when you have this configured, right, you can essentially kick off these jobs and at a relatively regular cadence, right? And of course, you can leverage Azure Machine Learning Studio and other things to sort of track your training jobs, track your experiments, and so on and so forth. One of the things that I like to call out with this particular post and just in general is, although you are using Azure ML in this case, by no means is it sort of a replacement to what you're currently doing, right? If you want to go ahead and not use Azure ML, if you want to go ahead and just set up your own container training jobs, set up your own Azure DevOps pipeline, these are things that you could do as well, right? And you have a little bit more control over if you don't want the dependency on Azure ML. This particular post is just kind of showing you, hey, if you are using Azure ML, here's a way that you might want to set up, set up your process here. And set up your pipelines for retraining automatically using the MLnet CLI, using Azure Machine Learning data sets, and using the Azure ML CLI, right, to execute these jobs. So let us know. There's comments down here, right? So let us know sort of what what your thoughts are around this. Is this something that you would find useful? Is this something that you're currently doing? What is your experience in general with this? Go on over to the ML.NET tooling repo as well if you find any issues with this, and just give us feedback, right, on just the experience in general and what are different ways that you would, otherwise sort of set a similar process up. So yeah, so that's that. In terms of other things that we're working on and we're sort of investigating at the moment is the DataFrame. So essentially, if you're not familiar with the DataFrame, essentially the DataFrame is just a way of representing data, specifically tabular data, with rows and columns, right? So one of this comes from it's implemented in various languages, right? So for example, if you use R for data science before, you may be familiar with the data frame. If in Python, if you use pandas, right, the data frame is a core concept for the data analysis and sort of data wrangling story, right? And those set of operations and workloads. So in .NET, we do have a DataFrame. It's under the Microsoft Data Analysis package. Now, if you don't know sort of the whole history behind this, it started off as an experiment in the Core Effects Lab repo. And as of last year, it came over into the ML.NET, the .NET machine learning repo, and has since been part of that. You're going to notice maybe you've seen it, that there's a few issues here in the .NET machine learning repo. And basically, there's been other things which we're going to talk about a little bit later that we've sort of been focusing on in bringing to both a model builder as well as the framework, so ML.NET framework, so the Microsoft ML set of libraries, right? So for the past year, the data frame hasn't really been a high priority for us. That being said, though, we have seen the issues, we have seen the comments, we have seen the feedback that you've given us, and we also understand that the data frame is a really important piece and a really important component to the overall data prep story for .NET and just for those types of workflows in general. So let me go ahead and paste this into the chat. But essentially, this is a tracking issue that I created. And you can find it in the repo as well. And basically, if this is something that you would like to see, if you have any feedback, if you have any comments, please go to this issue. Please provide your feedback and let us know what are some things that what are some things that you think are missing? What are some things that you think we can do better? I'll also be adding the issues. In this case here, I have all of the issues here, but I'll be also organizing them in terms of various sort of common operations that you would typically do here with data frames, such as creating data frames, right? Like reading data, as well as exporting data, things like reshaping. So renaming columns, resetting the indices, transposing data, filtering data, combining data. So merging joins is very common that you probably are going to have data from different sources and you want to bring it together, right? So things like that, which are currently available, but we understand that the experience could also be improved there. Things like grouping, summarizing data, handling missing data. So again, things that you find that are core to this particular sort of set of experiences, right, are things are things that we sort of want to hear about, as well as what exactly is it that what else would you like to see, right, that would make this experience the best that it can be for .NET developers. So yeah, let us know, give us feedback. We highly encourage that. Let's see. Okay, so now on to some of the stuff that we've been working on. So one of the things that we've been working on is support loading Onyx models using the GPU. Now you may ask yourself, well, I thought that this was already available in ML.NET and the Onyx runtime in general. And the answer to that is yes. However, what was not happening was, if you were to save the pipeline for making predictions and using Onyx models, the flag or the value to essentially use the GPU when making predictions was something that wasn't saved, right? So what this is going to do is it's going to provide a mechanism so that information is saved. So in the future, you don't have to basically recreate the pipeline every time. You can just pull in the model like you normally would any other sort of model and be able to make predictions on your GPU with the Onyx, with your non-Onyx model. Something else that's happening as part of our broader deep learning story is that TorchSharp now has support for .NET Standard. Now that's important because previously TorchSharp only supported .NET 5 and what's it called? And ML.NET targets .NET Standard, right? So to start some of those integrations of TorchSharp with ML.NET, we've basically enabled .NET Standard support. Okay. So you're going to hear a little bit more about that in the coming months. But these are some of the first and initial set of steps that we're taking to make sure that you can use and leverage TorchSharp inside of ML.NET. And if you're not familiar with TorchSharp, it essentially is just a library with .NET bindings for the libtorch library. So the library that supports frameworks like PyTorch. Okay. And then last but not least, this is something that Sharon is going to tell us a little bit more about, but I'll just sort of introduce it a bit. One of the things that we've been working on is bringing the AutoML experience that is currently available in Model Builder and the CLI, which leverages things like NNI, which is just a framework for doing automated machine learning, as well as Flammel, right, which is another framework. It leverages some of the best of those technologies to be able to bring you a really great and customizable and performant experience when it comes to using automated machine learning, right? Now, previously, we already have an AutoML API, but it could use improvements. So some of the improvements that are this sort of implementation of AutoML that's currently available in tooling, we want to bring that also to the framework so that you can also use it from a code first standpoint and have as much control and as much customizability as you would need or would want when it comes to that. Now, part of that includes having different tuners, having sort of APIs for sweeping over hyperparameters. And then last but not least, having a high level sort of experiment API. And again, this is also open for feedback as well. A high level AutoML experiment API that's going to make it easier for you to just simplify that experience of automatically training machine learning models. So with that, I'm just going to sort of hand it over to Xiaoyan here, who's going to show us basically some early prototypes of how this experiment API and AutoML experience works. So let me switch over streams here. Okay. Looks like I can see it now.
Hi. So thanks, Luis. It's really exciting to be able to share our team's most recent work here. And so let's just jump to a quick demo on how to create an AutoML experiment API and run it in the notebook, and finally monitoring inside notebook as well. So this is a quick demo. So, and this is just to set up some feeds and restore the packages and import common using. And all the metrics and the AutoML experiments are created in one small single cells. So you just have your pipeline, and in the line 4, you just load the CSV, use the DataFrame API that was just mentioned, and then you create your API, your pipeline. And this is the first magic command that I want to introduce, which is from the auto extension, and it creates a binary classifier, a set of the binary classifier with all predefined training space and all available trainer in the ML.NET. But if you want to use your own search space and your own trainer, you can also do it here as well. And after that, set up the dataset. And this is the second magic command, which allows you to monitor the training processes in the notebook output cell, which I will show afterwards. And this is the third magic command. So in this, when creating the AutoML experiment, you can just pass a tuner factories, and there are a lot of predefined tuners that for you to choose from, like the CFO tuner factory. This is I think there's a tuner that we work with Flammel teams, and it's good for quick start and also keep a balance of searching the entire search space and find the best hyperparameter for your parameters. And another available choices right now are random choice or the grid search tuner factory, but we are adding more smart tuners afterwards, like sequential model bias. And then you set up the evaluate metric, and then just call the run to start experiment. And this is the output. So this is output that you will get from the monitors. So it's just it will go through the. Let me first run this. When start, it will tell you the best run and the current active run, and it will show a plot that tells you how the trial goes. And so it will be updated while the training goes. And let me just, it takes 150 seconds. And you can also iterate all the trials in the final, in this final sections, and it supports user interactive. And right now you just you only have the option to go through the trials, but we will adding more features later. And this is how you create the AutoML experiment. But if you want to pass your own your own trainer and your own defined search space, this is also doable. So for example, if you want to replace the feature text which goes through the predefined choice for the n-gram, like Louis mentioned in the beginning of the meeting. You can also it's just again, this API is also still in preview, so we might make a few changes on that to make it simplify, but it's also available, and the other parts of the pipeline will still remain the same, and you will also gain the similar results by running this experiment. And that's all. Handing back to Louis.
Awesome, thanks. Let me just kind of get this back here. Yeah, so one of the things that I guess would call out is this is all still in preview and in very early stages. So please, by all means, go ahead and leave feedback. Let me see if I can pull up the issue here. The proposal for the experiment API. Okay, so I just went ahead and pasted it into the chat. Let me switch over to my screen. Okay, so this proposal experiment API, it's over in the .NET Machine Learning repo, issue number 6118. And yeah, basically this kind of provides the idea or the thinking behind the experiment API itself. So any feedback, any thoughts, would be greatly appreciated. Again, we want to make it as easy and as accessible for everyone to be able to use. I think, one of the things that really excites me about this is now you as a user are in full control over, how you define these pipelines, how you, what are you using as the metric that you're optimizing for, how your hyperparameter space is found, right? Or the optimal hyperparameters for your particular model are found. That's you're fully in control of that. So, you're not dependent on sort of either model builder or the CLI to make those choices for you, right? The other part of that really excites me is that it enables you to sort of build your own experiences, right? So, for example, if you were to say, hey, model builder is, works okay, but my customers, right, my end users who are inside of your organization, they have different needs than what model builder would otherwise give you, right? Now you can go ahead and embed very similar experiences and, in effect, right, build your own version of model builder, build your own sort of version of the CLI, right? And customize it as much as you would like, and put it basically anywhere that you like. If you want it on the web, if you want it wherever it is that you want, you now have that those capabilities, right? One of the things that I like to turn back to, could you pull the code back up, show you on the first example that you had?
Yeah, sure. There you go.
Okay, let me see. Let me add it back to the stream. Okay, yeah. So one of the things that we'd like some feedback on is, you'll notice the pipeline, right? And that very last section, that's exactly what the part that defines which type of problem you're trying to solve. So in this case, it's binary classification. So it's going to go out and it's going to try to find a binary classification algorithm that suits your particular data set, right? However, there's that top portion still, right? The portion where you are preparing your data and you are, creating features for the, to feed into this algorithm and to feed into this process. So one of the areas that we like feedback on is, what does this look like to you? Does this seem, I guess, something that you'd be okay with? Are there improvements that we can make in this area for the data prep processing? What are sort of the use cases or the workflows that you would sort of perform with this data prep, and how can we make that better? So I guess that's sort of a call for feedback there in terms of, what do you think of this sort of data prep experience, and how can we improve that? All right. So yeah, let us know. Let's see. So with that, I guess I'll open it up to any questions. Just have an open discussion over just in general, to any folks in the chat. Any thoughts, questions on any of the things that we've shown today. Let's see here. And if not, if I'll give it a few minutes here, but if not, we can probably have a short one today. And yeah, let's see here. And yes, Janice Q. It is very fancy. The other really cool thing is that, right, this is all running on notebooks, and as you saw, you have that if you're familiar with things like TensorBoard, right, that those visualization experiences that are tracking your experiments, that are tracking your runs, right, like you can build and customize those experiences, like it was shown here with that notebook monitor, right, that's making it easy for you to display. To this, not only to track progress, but also to visualize and display what that progress looks like, right? But yeah, let's see if there's anything else here in the chat. Nope, I'm not really seeing anything. All right, folks. Well, if there is nothing else, I guess I'd just leave you with a few things. Number one is make sure to, let's see, Paul Ward here mentions, you guys should reach out to Hassan Habib and talk about regular expressions. Could you elaborate a little bit more there, Paul? In terms of, is there anything related to regular expressions and ML or something of the sort? And while Paul is typing that, one of the things that, again, I would sort of call out here is make sure to check out the proposal for the experiment API that's over in this issue number 6118. The other thing is make sure to thumbs up and also comment on issue 6144, which you'll find over in the .NET Machine Learning repo. And 6144 is the issue with the data frame and being able to, make sure that the data frame has the support and has the capabilities that you would expect from a data frame like structure. And I see here, Paul Ward mentions there's some smarts around interpreting things like phone numbers. He obviously wants to make fluent. Okay. Yeah. I mean, if there's a Twitter name or something, or some other way to get in contact with Hassan, yeah, that'd be great. Love to reach out. Yep. Give it another second here for questions, but if not, we can, as I mentioned. Yep, NML could do wonders here if applied right. Yeah, it can. I mean, I think this is one of the general, sort of questions that folks tend to ask themselves at first, right? So you mentioned regular expressions here, and one of the things that even before starting, like machine learning, is that you should ask yourself that question, right? Or it's good to ask yourself that question where it's like, let me just sort of just bring us both back in here. So ask yourself that question of, do I even need machine learning, right? And typically, I guess the sort of the cutoff or what's going to be the decision factor is, can I come up with a just in general, like a good enough heuristic, right, for solving my problem? For example, let's say that, I don't know, you were building some sort of spam filter, right? And you're building rules inside of your Outlook or, whatever your mail application is. And if, I don't know, Twitter user XYZ is constantly spamming you, right? You can just write a rule that says, if I get any email from Twitter user XYZ, just throw it in the trash, send it to junk, right? And that's a good enough heuristic and it works, right? But as you start to scale, right, especially in scale problems where it's very difficult to really know, or just just write rules for all these edge cases, that's sort of where ML and it becomes a little bit harder to apply just general heuristics to, and you need ML could potentially benefit you there. So yeah, Paul, it's possible that for this particular scenario of regular expressions, machine learning could be applied as well if regular expressions themselves are no longer doing the job and handling those sort of edge cases, right? So you have a question from Andretti Mattia, and I hope I sort of pronounced your name right there. Apologies if I didn't. Yes, you can use ML.NET with Raspberry Pis. In fact, let me see if I can find a sample application that I recently did. But long story short, yes, you can run ML.NET on Raspberry Pis because it runs on ARM devices. As I kind of called out earlier in sort of the session. Some scenarios may be limited for training. And one of the other things that I'll call out is like, that's probably okay, because chances are that because ARM-based devices are typically not as powerful as say your x86 or different types of processors. So probably what your workflow, the workflow that you will most likely be performing is you'd be training on perhaps a larger machine, hopefully with me because you have a lot of data or whatever it may be, and then you're just using it to make predictions inside of a Raspberry Pi or any other sort of ARM-based device. But yes, you certainly can do that, and that's probably a recommended workflow there. We see Janice Q here sort of recommends using the Jetson family for ML, and yeah, their hardware is a little bit more appropriate, especially if you're doing some sort of like retraining workflow or retraining pipeline. That's something that you might want to take a look at. And I think maybe somebody from the community may have even built some samples using Jetson, if I remember correctly, or Jetson based sort of hardware. Let's see. So Paul Ward asks, is it possible that you guys could build a plugin to ASP.NET Core, allowing it to learn over time bad stuff calling my apps? Yeah, so that it could filter out I could feel things like bad requests over time could then start filter out certain IPs or something. Yeah, so that's actually a really interesting scenario that you bring up, Paul. Let me see if I can find it. And let me share my screen here again. 1 second. So a couple of years ago, we had a hackathon, and one of the top projects that we had. Let me just switch over here to my screen. One of the top projects that we had was pretty similar to what you're referring to here, Paul. And basically, it was some sort of like network monitor. By the way, if you're interested in seeing the samples, you can check out the .NET Machine Learning Samples repo. We have tons of samples there as well, if that's something you're interested in checking out. But let me go over to the community samples, because that's where it is. If I can find them. Community. Sorry, apologies here. Just taking me a bit of time to find the community samples. There we go, community samples. So if you go over to this malicious packet detection, right, you can find the solution here. I'll paste this into the chat as well. And yeah, basically what Mike did here was he went ahead and trained a machine learning model using, he mocked the data, so he didn't generate the data set, but I could imagine if you have logs, right, you can essentially do something similar where you're tracking, here are the logs or the types of content, right, and requests that are coming into my system that I'm flagging as malicious, right? So if you're interested, make sure to check out that project from Mike. I think, I believe that there's a video as well explaining sort of the entire solution. So there's a lot of really, really good content there. Yeah, and then Paul, I see you sort of clarified there that you get for my PHP admin pages, but all your apps are in .NET, so bot traffic. Yeah, so I would encourage you to check out this sample that does pretty much something similar. I think Mike used Wireshark and your standard network analysis tools to sort of perform some of this analysis as well. Yeah, so check it out. Jonas here asks, what about Torch-Sharp in Fsharp? Yeah, it's it's something that let's see. Sorry. I think that's what it is. Torch-Sharp samples. I forget what the repo is. Torch-Sharp examples, maybe. Apologies here for examples. Not part of it. But long story short, if I go to Torch-Sharp, I'm pretty sure I'll find it. Yes, there are samples in Fsharp, and actually, it is encouraged that if you ever post a sample for TorchSharp, that you also have some Fsharp samples that are associated with it. So let me see if I can find it in the actual repo. So there's a release notes. There we go. TorchSharp examples repo. So if you go ahead and check this out, there's actually a bunch of tutorials. Let me see here. Go over to the tutorials, and you'll see here that there's both C# and Fsharp. So yeah, and the other good thing here is that they are all notebooks, so you can just go ahead and check them out. And yeah, let's see here. Whoops, I tried to get rid of my screen, and yeah, instead ended up getting rid of myself on stream. Okay, yeah, Sharafuddin, happy to share those resources, Global AI 2022. If you have other samples, actually, we would strongly encourage you to, let us know, right? Just contact us on Twitter and stuff, and we look forward to seeing other samples that you may find from the community. We're always very happy to highlight what's happening in the community, and just seeing the really awesome things that people are building and that they are presenting. Speaking of, it actually is a really good reminder. If you have any sort of feedback in terms of the things that we're doing here on the stream, or, things that you would like to see in terms of content, things that you think we should improve, make better, whatever it may be, there's that link right there, the HTTP aka.ms MLnet Standup feedback. If you hop on over to that, just let us know, how can we improve? How can we make this better? Because at the end of the day, this is really your time. This is really your space. So whether it's asking questions, whether it's learning something new, learning about the things that we're building and that we're working on, it's really just a way for us to communicate with you and to hear the feedback that you have for us. So we really appreciate it. Yeah, we strongly encourage you to let us know how we can improve. So I'll paste that into the chat. Okay. I think it should work, maybe. Yeah, anyway. Okay, so let us know if there's anything else that you'd like to chat about. And if not, like I said, we'll be happy to give you some time. And yeah. Oh, there's one thing that I would call out. I don't know if any of you are attending DevIntersection, which is a conference over in Las Vegas happening next week. But one of the things that you should, there's actually going to be a lot of sessions that are happening around ML.NET. So I'll be doing a few sessions, one on ML Ops, and one just an introduction to ML.NET in general for folks who may not be familiar with it. There's also a few sessions happening around tokenizers and just using language models like BERT for different tasks using ML.NET. So make sure to check those out if you're over in DevIntersection. And if you are at DevIntersection, you'd like to say hi, I more than welcome it. I would hope that you're around. And yeah. Anonymous user, you say, have you seen my question? We have not. I don't see if there's anything here from you. So if you'd like to ask it again, by all means, please go ahead and ask your question, and we'd be happy to answer it if we can. Okay, let me get rid of this here for a sec. While we're giving anonymous user a chance to type their question here. But yeah. Let's see. I guess a question that I would have for some of you folks is, when it comes to, I tried to implement very hard for me to improve in that area. Okay, so anonymous user. I tried to implement BERT a year ago, and it was very hard. Are there any improvements in that area? Yeah, I'm glad you asked. So let me actually pull up my screen again, and sort of go back to the .NET machine learning repo. Yeah. So if we go over to the machine learning repo, one of the things that you're going to be able to see it's going to be our roadmap. All right. So there's a few things that we're focusing on over the next year. So one of them, as I sort of mentioned, was that most recently has been the DataFrame, and we're starting to sort of try to create a plan around that. But some of the things that which we talked about today, right, are some of the things that we're working on. One of them is deep learning, right? And as it pertains to deep learning, there's actually a tracking issue here that gives you a little bit more detail what our plan is for deep learning. Now, yeah. So the plan for deep learning. So one of the things that we're trying to do here is make it easier to consume Onyx models. We know that it's a pain point for people in general, and this is not just a sort of .NET issue. This is just a standard Onyx sort of experience, right? That it's very hard to know what my inputs are going to be, what my outputs are going to be, what exactly are the transformations that I need to make, right? So trying to find ways to make it easier to consume Onyx models. The other thing that we talked about was to support Torch-Sharp integrations, which goes back to sort of what I mentioned earlier, that now Torch-Sharp is targeting .NET Standard, right? Making it easier for us to integrate. And then last but not least is building sort of this bridge between Torch-Sharp and ML.NET. Part of that, which is going to revolve around particular scenarios, specifically NLP. So the scenario that we're targeting right now is NLP. And we're seeing at potentially doing a bird implementation for those NLP related tasks as part of this Torch-Sharp integration. It's still in its very early stages, but it is something that we look to support as we start building out some of these integrations with Torch-Sharp. That being said, there's also a few community samples. I don't know if you've seen this project from Nicola over from Rubik's Code. So I think it was called birds tokenizers.net. So if I try to find that, yeah. So let's see here. Yeah, so if you check out this this article here, I'm going to paste it in here. Yep. Yeah, so that's essentially. But in terms of, I guess the question that I'm not, I guess maybe I'm not understanding, Anonymous, is what sort of improvements would you like to see in this area? Because currently we're working to essentially be able to make the experience of building one of these sort of solve these types of problems, like NLP type problems, using bird implementations or similar implementations for NLP scenarios. But beyond that, what are, I guess, the improvements or pain points that you would like to see addressed as part of this? So Paul, yes, you see, every time I see ML solutions, it's a lot of code to achieve simple things. Is there a plan to package stuff like my idea in a few lines so that there's prepackaged ML models we can use? So one of the things that kind of addresses that area, Paul, is things like transfer learning, which we're actually currently already doing with things like the image classification. Image classification basically takes or the image classification API in ML.NET takes a pre-existing model that's been trained before, and it just basically gets updated based on your data, right? And the process of doing that is relatively simple, relatively high level, and it achieves pretty good results. We are always looking for sort of top scenarios, right? We obviously can't address every single scenario, right? Because everybody's going to have different needs. But for standard things like image classification, things like object detection, we can provide those sort of pre-trained models that you can build on top of using transfer learning, right? So that's the idea there. So that's sort of like it's not a full solution, right? Like we're not going to be able to provide, again, because everybody has different needs, right? And perhaps if that's sort of an area that you're looking for to have just prepackaged models, right? Where you're not actually doing the training and you're just basically consuming something that somebody else has built, right? There's already some solutions out there like cognitive services and things like that. The trade-off there is, right, that it's prepackaged, so you don't have that option of going and adding your data for a few of those scenarios. You don't have that option of going and adding your data and training your custom solutions. That's getting better, but yeah, it's not applicable to all scenarios, right? Yep. So let me take a step back even and address Paul's question, BERT. So BERT is a language model for natural language, different types of, well, let me take it back even. It's a sort of like a structure or architecture that tends to be good for natural language type problems. So things like text classification, question answering. I believe there's also a name entity recognition, but I forget. But the point is, it uses this transformer-based architecture, which is a type of neural network, to solve those types of problems. And it's so far it's been one of the BERT, among with many others, transformer type architectures have been sort of the natural language processing sort of state of the art type of solutions for those problems. And yes, they are for NLP solutions. And then for anonymous user, integrating the encoding and decoding in the pipeline somehow instead of doing it manually. I see. So you're referring to tokenizers, is that correct, anonymous user? Having different tokenizers? And if so, anonymous, that's actually something. Okay, I see what you mean. Yeah, so we're actually in the very early stages, and some of the work that we are doing involves, it's going to require work around tokenizers. So what I would encourage you to do is actually post over in the .NET Machine Learning repo, and post this issue, right? And I can thumbs up it. We can sort of thumbs up it on there, and yeah, because yeah, so we understand that tokenizers are going to play, they're needed for these types of solutions. So there's going to be some work around that. That being said, though, because there's different tokenizers, different models, there's going to be limitations around sort of which tokenizers get implemented, right? So, but again, we'd love to work with you. If you're the person that I'm thinking of around sort of the first implementation of BERT with ML.NET. We'd love to work together and just get that feedback on how can we make that experience better. And Paul, yes, that is a scenario, right? So things like text processing, voice processing, that's those natural language style problems. That's kind of what BERT lends itself very, very well for. Yeah. So I think there's a few related questions here. Paul, you mentioned ML is too so abstract. It's hard to figure out how it might be useful without a lot of time to put in. I would encourage you, if you are doing .NET development and if you are, sort of getting started, I would encourage you to start with the tooling. And AutoML kind of helps with this as well, right? If you prefer those code first approaches, I would encourage you to go ahead and give things like Model Builder if you hadn't tried it before. And if you had, we'd love feedback on ways to make that better. But if you haven't tried things like Model Builder, go ahead and take it for a spin, right? There's going to be limitations, of course, right? But we provide you with the code, so you can, once you're done training a model for a particular sort of scenario or task, right, you can then go ahead and essentially get the code gen, so you can go ahead and tinker with the code, right, and sort of see how things were built. Notebooks are a really great experience, or a really way of sort of getting started as well. For the folks in the chat, I see that you're asking how to start. I would encourage you to start with Model Builder and just in general some of the tutorials that we have available over in our docs. And that's probably a good way to get started there, and just learning how you can use ML.NET. A lot of the stuff is applicable throughout various frameworks, so you can do it that way as well. And I think if you're not doing .NET, there's also other data science type sort of courses that are out there. Yeah. So yeah, make sure to check those out. Let's see, current comment. We are getting close to time, but let's see. When I talk to Hassan, yep. So Paul, you mentioned here, right? Talk to Hassan. He wants to build a more human library that can build regex. Yeah. So text generation, right, is one of those areas that things like BERT also I believe help with. So yeah. And an anonymous user, yeah, it's complicated. Yeah, it's very difficult, right? Because the tokenizers tend to be very model dependent. So yeah, it's definitely challenging to try to, I think, being fairly transparent here, like the stuff that Hugging Face has done, for example, right, with their Transformers library, right, is really great. But again, that building up those set of tokenizers definitely takes those encoding and decoding sort of components, right, definitely takes time. So we're definitely going to sort of start out with some of the ones that we'll need to sort of enable these experiences inside of ML.net. And again, we're definitely welcome to that feedback, and we want to work with folks like you to help us make that experience great. Yeah, and yeah, I believe that stay tuned, Paul. We in the coming months we are going to be sort of introducing some of these integrations with Fsharp and making it relatively easy to use some of these, right, for NLP based tasks. Text generation, I don't believe, is one that we're going to focus on as sort of one of our main areas or scenarios that we're going to be trying to solve. But again, right, as we hear feedback and as we hear more from customers, like, hey, this is what we'd like to see, this is what we'd like to, these are the things that are important to us, we're definitely going to take those into account. But with that, we are actually over time. So I would just like to, again, encourage you to comment on the DataFrame, comment on so the experiment API, which we showed you earlier today. I would also encourage Anonymous, please go open that issue over in the .NET Machine Learning repo on tokenizers and being able to sort of integrate those as part of the entire machine learning pipeline in ML.net. And like I said, we'll thumbs up it, and we'll make sure that that's something that is considered, and we work with you and folks like you to make that experience great as we deliver these NLP based experiences. So yeah, with that, thanks so much, folks. We'll see you next time. Take care.